continue our next section of Calculus 2, section 7.4, Earth length and surface of revolution. So let's take a look at the definition of Earth length. Let the function y equal to f of x represent a smooth curve on the closed interval ab. The earth length of f between a and b is an integral from a to b square root 1 plus derivative of a function square dx. You use this formula when your function have a variable x. Similarly, if you have a function with variable y, the earth length of the function between c and d is an integral from c to d square root 1 plus derivative of the function square dy. Now let's take a look at an example. Find the earth length of the graph of y equal x to the cube over 6 plus 1 over 2x on the closed interval 1/2 to 2. So because the function have x variable, you're going to use the formula an integral from a to b square root 1 plus derivative f of x square dx. If you graph the function, you will have a function as represented to the right. And because they want to find an earth length between 1/2 to 2, it's going to be the distance here as you see on the red ink from 1/2 to 2. This is the earth length that we're looking for. Now before I substitute in the formula, I need to find the derivative of a function. I rewrite the function as 1/6 x to the cube plus 1/2 x to the negative 1. Now we're going to take the derivative of this. So the derivative of f of x would be 3 over 6 x to the cube, to the square. Square. Minus and plus would be minus 1 over 2, but you would have x to the square on the denominator because -1 and -1 is -2. I'm going to rewrite this a little bit as 1/2 x squared minus 1/2 times 1 over x squared. From here, I will factor out the 1/2. If I factor out the 1/2, I would have x squared minus 1 over x squared. So this is our derivative f of x. Now we're going to substitute in the formula to find the earth length. So s will equal to an integral from 1/2 to 2 square root 1 plus derivative of a function with this whole thing, which is 1/2 x squared minus 1 over x squared quantity square dx. Alright, so this is a pretty complicated functional expression to take an integral. So what I need to do is to simplify this and be able to take it out from radical and make it simpler and easier to take an integral. So let's continue our simplify this. So I have an integral 1/2 to 2 square root 1 is just 1. Now I have to square this whole thing. So 1/2 somehow disappear. 1/2 square is just 1/4. Alright, and then I have to square x squared minus 1 over x squared. You can do x squared minus 1 over x squared times itself twice, or use the formula however you feel comfortable. If I do that, I would have, I'm going to use the formula here, first term square minus first twice first time last plus last term square, which is x to the 4th. Alright, so I square this, which is 1/4. First term square, it should be x to the 4th. First term square minus twice first time last plus last square dx. Alright, let's simplify some more. The idea of this, I want to be take all of this out from radical, then take an integral. So I have an integral from 1/2 to 2 square root this big long expression. Let's see, let's simplify a little bit just to clean it up a little bit. So I'm gonna have 1 plus 1/4. I'm gonna have x to the 4th. The x squared cancel the x squared. I left with minus 2 plus 1 over x to the 4th dx. Let's see if I make any mistake here. So I have x to the 4th, 2 x squared plus 1 over x squared. Yes. Next step I would like to do is distribute the 1/4 inside. So integral 1/2 to 2 square root. So this is 1 plus, now I'm gonna distribute the 1/4 inside the square root here, the parenthesis. So I'm gonna have 1/4 x to the 4th power minus 2 over 4 is 1/2, and then plus 1/4 x to the 4th on the denominator dx. So we just have to keep cleaning it up and then find a way to take it out from the radical. So from here I'm going to have an integral from 1/2 to 2 square root 1 minus 1/2, you're going to have 1/2. So I'm going to have 1/4 x to the 4th plus 1 minus 1/2 is 1/2. Plus 1 over 4x to the 4th dx. Right? So let me rewrite this a little bit. This is 1/2 square to the 2, I'm sorry. I'm gonna rewrite this way. This is 1/4 x to the 4 plus, instead of 1/2, I'm gonna write 2 over 4 plus 1 over 4x to the 4th dx. Alright, now it's look better. I'm gonna factor out the 1/4. So an integral 1 over 2, 1/2 to 2, square root. I'm gonna factor out 1 over 4. Then I will have x to the 4th plus 2 plus 1 over x to the 4th dx. Now, because I factor out the 1/4, now this equal to an integral from 1/2 to 2 square root. Right, I need to take it out from square root, so I'm gonna have to rewrite it this way. 1/4 is 1/2 square, and this one is the same thing as x square plus 1 over x square quantity square dx. Right, so we're almost there. So the hardest part here is take it out from the radical, simplify it. So an integral from 1/2 to 2. Now this one I have 2 of them, this one I also have 2 of them. I can bring out the 1/2 because it's a constant, because they take out of the square root is just 1/2, and then you left here with x square plus 1 over x square. The radical disappear because you have 2 of them. Dx, now it's easier to take an integral. Then you would have 1/2. I'm going to take an integral from each term. So the first term, I'm going to have x to the cube over 3. The second term, I'm going to have 1 over x, because this becomes x to the negative 1. And my lower bound would be 1/2, and my upper bound would be 2. And if you simplify all this, your answer would be 33 over 16. Alright, so that would be your arc length for this example.